Hello, everybody. My name is Saif Afat. I'm a radiologist from Tübingen, and I would like to welcome you to this course, the ESOR Sustainability course with the topic Waste Management and Optimizing Procedures, Protocols, and Resources. I am honored to moderate the first part, and we have two talks or two parts in the first one. The first one is about From Waste to Worth, Sustainable Management in Radiology, done by Laurie Ramsey, and the case presentation by Samuel Taylor. And then we have a Q&A session, and then we have a small break to part two. We would like to encourage you all to post your questions in the Slido. You received the link. You don't have to wait to the Q&A. Feel free to post your questions anytime, and there are no stupid questions. So please feel free to post them. And Laurie, the stage is yours.
Thanks very much. I'll just get my presentation up and start sharing my screen. Hi, everybody. Thanks very much for attending today. My name's Dr. Lauren Ramsey. I'm a paediatric radiologist from a place called Frimley Heath, which is just outside London. I'll be talking about waste across the whole of England, really, but specifically some of the numbers are from my trust, which is about a 1,400 bed trust across 2 sites with several peripheral hospitals, just to kind of give you an idea about how the numbers relate to your own institutions. And I make it clear that I'm a paediatric radiologist because I think this is probably an area in which we're all kind of just beginning to get involved with. I'm much more comfortable about standing up and talking about malformations of the paediatric foregut than I am about sustainable management, kind of waste management and how we can make changes. So I really want to encourage everybody to post questions in the Slido thing at the bottom. Any question from the specific about various projects to the existential would be really, really very gratefully received, because I really think that the way that we can build momentum is to be collaborative. We don't want to reinvent the wheel. We want to kind of be able to build on each other's successes. So I have no conflicts of interest. I do not own shares in any plastics companies. And so I'm going to start talking about why we should manage waste. This is what happened in my trust 6 years ago when too much iodine went into the waste stream. The smoke turned pink. It was obviously a bit of a problem, and there's lots and lots and lots of different chemicals, body parts, kind of radioactive materials that go into the waste streams. But very specifically, there's quite a lot that isn't that. So the climate impact of radiology is that radiology departments apparently produce 1% of global worldwide emissions. That's such an astonishing statistic, and it's a statistic that I look up and check every time I say it, because every time I think that can't be right. It was published in the RSNA paper. I've checked it several times, and it's such an amazing thing to look at. Largely, it's because of carbon emissions, because we have such a lot of energy-intensive machinery. But the real reason why I say that is because I think that we need to remember why, as healthcare professionals, we care about this. Climate change is likely to disproportionately affect vulnerable populations and exacerbate existing health and social inequalities. There's a kind of saying from the climate activism world that there can be no climate justice without social justice. But I think that that's really, really important for us to remember, that our populations, I'm a paediatric radiologist, but all of our marginalised populations are likely to be disproportionately affected by climate change. So it's really important that we get this right within radiology, but within the wider healthcare environment. In healthcare, approximately 85% of waste is general waste. So that's non-infectious, non-reactive, and non-radioactive material. So there's huge scope for reducing the amount of waste that we produce. And importantly, there's huge scope for reducing the temperature that we produce it at. There will always be a requirement for incineration. You can't put a gangrenous foot on a compost heap, but that's obviously not appropriate. But there's lots and lots of stuff that we produce within healthcare that could be either not disposed of at all, e.g. not used in the first place, or reduced in terms of the temperature at which it's disposed of, which overall has a much lower carbon impact. Production, manufacturing, use, recycling, disposal, all of the products used in healthcare carry an environmental impact. And it's really, really important that we look at all of the little things that all add up as you kind of move through your day. All of the things that you use, all of the products that are available to you will carry quite a significant impact. And then at the end of their life, they'll carry a significant impact in terms of the way that we dispose of them. So I think it's worth pointing out that 99% of plastic is made from fossil fuels. Obviously, it's closely linked to climate change. And plastic waste is commonly focused on in like eco plans that people make. But all products, regardless of the material, carry a carbon and also a financial cost in production, transportation, and end-of-life management. The reason I highlight the financial cost is that it can sometimes feel like we're kind of rowing upstream, making changes because they're sustainable, whilst very nice, doesn't always carry a great deal of impact. But quite often, a change that is more sustainable will also be a change that is cheaper, particularly if it's a question of not using something. And I've really, really found that in my department, but also in our wider trust, getting the cost-saving team on board with my eco suggestions has really helped to drive things through. I recommend that you get to know your cost-saving team if you haven't already. The classic reduce, reuse, recycle slogan, beloved of environmentalists, I think carries real relevance in planning a radiology department strategy specifically, but across the wider healthcare environment. And also it's just a way that you can structure your thoughts about which things to do first, which things to do next, and which things to wait for a bit later. So there's the most riveting document that you will ever read is the NHS England Clinical Waste Strategy PDF. There's actually some really cool facts and figures in there. For example, in England, 150,000 tonnes of clinical waste is produced per annum. And the vast majority of that is treated with high temperature incineration. Basically, natural gas is pumped in, it's burned at an extremely high temperature. The energy that's produced when it's burned is fed into the national grid, so energy from waste. And then the bottom ashes, which are like the rubbly bits, go to produce the bit that goes under the tarmac in potholes on roads, and the top ashes go to breeze blocks for construction. That's the same across the whole of England. All NHS trusts will do that across England. Depending on where you work, you may find that different places in your areas do different things. But that's a kind of part of the NHS England clinical waste strategy. And the clinical waste is burned at between 850 degrees centigrade and 1,100 degrees centigrade. This clinical waste strategy, which is this document, estimates that £11 million per year and 30% of the carbon emissions from waste can be saved by proper implementation of waste practices. That's quite a big scope for modification. And mostly the way that they intend to meet those targets is by changing what temperature things are burned at, e.g. putting things into the correct waste streams. If you walk through your hospital, you will see a billion things that need to be disposed of. This was a 30-second quick brainstorm that I did. You will have very many different options. All of those things carry a carbon impact, and all of those things probably are useful. They might not all be necessary to doing your job in the way that you want to do it. And I really urge you to kind of set aside your preconceptions and just wander through. Just notice what's being used, notice how things are being disposed of, notice what bins are where. It will really open your eyes to the way that waste is managed within the hospital. So these are the NHS waste streams that we've got. There's also food waste, which is anaerobic digestion for slurry that has recently been introduced. So basically it goes onto farmers' fields. At the moment in my trust, only the canteen sends its waste for slurry. Hopefully we're going to extend it out to include ward and domestic kitchens. I might just touch on that at the end if I've got time. But today I'd really like to talk about offensive waste and infectious waste, which are the two biggest streams of waste, and also quickly touch on confidential waste. So the biggest streams are, at least in NHS England, are Tiger Stripe and orange bins. They cost us 25p and 35p a bag in comparison to the domestic waste, which costs 10p per bag. They're both burned at 850 degrees by pumping in natural gas. But the way that they differ and why it's more expensive to put something in an orange bin rather than a tiger stripe bin is that it's different in the way that they're handled. So they have to go on special trucks. If it's in an orange bin, they have to be burned within a certain amount of time frame, etc. The aim of all waste management, or at least all sustainable practices in waste management, is to reduce waste overall. Obviously, we can kind of put signs on the bins and you can put things in the right places and stuff, but there's always going to be human error. And if we can reduce what you've got to put into the bin, then you produce less waste overall. So that's the first bit, the reduced section. I walked around my department. I kind of peered in at some doors. I saw people doing some stuff. And I thought about what wasn't necessary. It will be different in each department. Local practice differs. People do different procedures. People do the same procedures in different ways. Different people will have their own specialist kind of ways of doing things. And I have to say there may be some resistance to you saying, actually, do you really need to use that? My experience is that most of that resistance was due to change. People didn't want change rather than any material objections. And I'm going to run through a very kind of quick case study about how I changed one thing. What I have found is that in the reduced category, the cost-saving department was my best friend. So I would make a suggestion. Quite often I would meet resistance, but if it was saving the trust money, the cost-saving department got on board. And at that point, I had a great deal more clout to kind of enact my changes. The good thing about these reduce kind of options are that they're quick, they're potentially quite easy, they build momentum, they build excitement about sustainability within the department. My first big thing was the paper couch roll. I don't know who uses this, but I'm a pediatric radiologist. I do a lot of ultrasound. The kids would roll around in it, they'd eat it, they'd get tangled in it, it would end up covered in jelly. And I thought, do I really need this? So I got in touch with infection control. And they agreed that the paper was for cosmetic reasons only, that the couch should be cleaned in between each patient, unfortunately with a single-use disinfectant wipe at present, but we might be able to change that. And they agreed that it wasn't necessary. It was for cosmetic reasons only. So I suggested that we got rid of it. CT went from 3 orange bin bags of waste per day to 0.5 bags per day per scanner. That's across the whole trust. So we've got like 13 scanners across all the different places. That's a lot of waste saved. We do still use some, particularly in ultrasound. So if we're doing a nappy off procedure or an underwear off procedure or a radiologist's discretion, if a patient's got kind of skin problems or whatever, we will still use it. But it saved the radiology department £14,000 per year. That's obviously a considerable saving. I kind of have to use £14,000 as a substitute for the amount of carbon saved because I have no way of measuring how much carbon was saved. But it gives you an idea of what considerable scope there is just making some really simple changes. That number is just the procurement number. So it doesn't count the number that is saved in reduced waste volume. And obviously if bags and bags of orange bins are being put into the incinerator, 35p per bag adds up. So there's quite a considerable carbon and cost implication. And because it was a major cost-saving exercise, it ended up being rolled out to all other outpatient clinics, the emergency department, obstetric scanning, mobile units, etc., without any further input from me. It was deemed to be a cost-saving exercise, and it was rolled out. So I have no figures on how much carbon was saved across the trust with this one very simple change, but I think it will be really significant. I have to say there were quite a few objections initially. Patients don't like it. So before I rolled it out, I did 6 months of ultrasounds, just me, not using the couch roll. And I had one objection over the course of that 6 months. The patient was like 36 hours old. The parents were worried that the couch might be cold. I actually think that's quite a reasonable worry. We put a blanket down. It's not really a material objection. I've never had any other patients say that they have a problem. There was a suggestion that it might prevent wear and tear from shoes on the couch. but it's like, it's paper tissue, you know. I don't think it's really a significant situation. And then one section said, well, it hides the tears in the upholstery. It makes it look better because we've got really old couches. But actually, with all the money that we saved, we were able to reupholster the couches. So then that was also not a problem. So there's plenty of other reduce ideas, some of which I've got in progress, some of which I've just thought of. I'd really, really like it if you guys could stick any ideas that you've had into the chat so that we can start to generate some thoughts about this. We put disposable cups at the water stations away. We put them behind the receptionists, you know, where the receptionist sits. They now hold onto the water cups, and had a sign up saying you have to ask for a cup. Most people carry water bottles, some people don't. So we've reduced paper cup usage by 75%. Again, the cost saving team is quite happy with that. We've created procedure packs for radiology, which basically means that the basic things that all the breast biopsy team will use, the CT lung biopsy, some of the IR guys use, I use for Mickey cysts. All of the basic stuff comes in one pack, which means that we've eliminated all of this single-use packaging. That was essentially a question of watching people do their procedures and making a spreadsheet of the things that get used by everybody. That's been quite good, actually. We've introduced single patient rather than single use slide sheets, which travel with patients throughout their inpatient stay. Still early days, but significantly less waste. I urge you to look at this. When I was at Great Ormond Street, this project was happening, nothing to do with me, but I think it's really interesting. It's the Gloves Off project, which is a way of making sure that people are using disposable gloves at an appropriate time. And we've had a trust-wide transfer to the electronic patient record system. Obviously, that's not my project. So reuse is another option. It's obviously quite tricky to isolate it to the radiology department. We have a decontamination department, so I just basically went down there and said, you know, like, what have you got? Had a look in their cupboards. We found some gynae equipment that we could use that was deployed for the hycoses. So rather than using single-use speculums, we used reusable ones that were decontaminated in between each patient use. There's a project that is taking electronic equipment and furniture and either redeploying it or refurbishing it and sending it to auction, which is quite cool. And then the final thing is recycling. Domestic recycling is available in my trust, but it's rubbish. Huh. Funny joke. It doesn't, it's really unclear what goes in there. It's got like banana skins and stuff. I'm sure most of it gets dumped basically because the waste stream is so contaminated. But we do have quite a good system for the confidential waste, which I'm going to talk about in just a second. We also, I think I mentioned at the beginning, have started a service that collects food waste. Anaerobic digestion is quite complex in terms of the environmental impact, and I'm absolutely not going to go into it now. But it's definitely better than it going to landfill or being burned, which was the other option. The confidential waste has been really brilliant. We have started a service whereby all paper and lightweight card in our trust should go into confidential waste bags. So basically, we have these big white thick sacks. That's shredded by a company, and we sell the shredded material. So we get paid for the material that we're producing, and it goes for animal bedding and packaging. The trust is paid a small amount. They wouldn't tell me how much, but I think it's like a few pennies. But at the moment, we're producing approximately 1,000 bags a week across the trust. I think we have scope for getting it up to about 2,000 bags a week. And it's true recycling. So at the end of life, the finished product is either composted or it's recycled. And it's really, really effective because no one puts a banana skin in the confidential waste bin. So it's a high quality product. And it means that all of that stuff is being diverted out of being burned or being put into a domestic recycling bag that is, quite frankly, not really fit for purpose in our trust as it works out. So in summary, first of all, reduce. If you are using products, if you look at your suite of products that are available to you and you realize that some aren't necessary, that's a whole load of stuff that doesn't need to be burned or recycled or disposed of at the end of its life. Anything that you can reduce will have a considerable carbon saving. Then you can apply the reduce, reuse, recycle slogan. Reuse and recycle, there's some options. I found them much more difficult to implement into day-to-day clinical practice. And I'm hoping that we can build sustainability products into the quality improvement project. So the registrars, as part of our training schemes, are required each year to do a quality improvement project. Usually that generally tends to be kind of service provision projects, but I'm hoping that we can bring in some sustainability projects to that as well. Like I've said all the way through this, I am by no means an expert. I'm enthusiastic, but it would be great to have other ideas, other people that we can work with. And I think this is an area in which collaboration, like we're not doing anything particularly impressive or complex. It's just someone has to think of it and someone has to figure out a way of implementing it. And if we can collaborate so that the thinking part is already done, we can hopefully build some momentum to produce some good results. Thanks very much, everybody. Any questions in the thing at the bottom?
Thank you very much for this amazing presentation. I must admit, everybody can feel the energy and how much you like this project and how you act. We have a couple of questions, but I think we go with the second part, and then at the Q&A we can speak about some questions. I also have a couple of questions for you. So Sam, the stage is yours.
Hi, good morning, good afternoon. My name's Sam Taylor. I'm a reporting radiographer for Imperial College Healthcare NHS Trust in London. And I've been invited this morning to come speak to you about a case study of a specific project we worked on in Imperial. No conflicts of interest as clear. So I'm going to briefly go through the background context of environmental sustainability and imaging, a brief history of something our directorate put together called the Environmental Sustainability Group, and then we're going to go straight to the case study of a contrast bottle waste management project that I worked on. And the overall aim is to describe some like a practical project and some actual steps you can take, either for this project or for a similar project, about how to do that in your own department. So, slide's a bit slow. Sorry, matches. So if we go back one slide. So again, to carry on from what Dr. Ramsey was saying, radiology is about 1% of all admissions globally. Again, I also had to look this up several times because it doesn't sound right, but it's true. The reasons for this is high state usage. We have high energy costs for our equipment. That's scanners, that's our workstations, reporting stations. We have high energy costs, data centers, image storage, high disposable and single-use consumable usage, which is what this project was around. And then we also have lots of indirect emissions because we can't do, it's very difficult for us to deliver our care remotely in radiology. Sorry, the slide's a bit slow. So nationally, in the UK at least, imaging staff are very conscious of the high emissions related to their workplace. They're supportive of change, but they don't necessarily know where to begin or what practical steps to take forward. So we set up a thing called Environmental Sustainability Group. We had staff from across the directorate of various staff groups and bandings, clinical scientists, management, radiologists, radiographers like myself, nurses, healthcare assistants, administrative staff, and having that spectrum of staff across the bandings was really useful for like collaborative working. They can open doors that you didn't even know were closed to you getting your project through. We also had staff across the trust, which for us is 3 sites plus our satellite diagnostic centres, and we just met monthly to give updates on our projects and look for help. The first thing we did was to survey the directorate. Like, are we the only people who care about this? And in line with the national survey, attitudes were extremely positive for environmental sustainability. And then we drill down a little bit further and we find like the specific enthusiasm for smarter waste management, informed guidance on modality specific waste. So which bin does which bit go into? So we looked at the different waste streams and the costs. Obviously, clinical waste and sharps bins are the most expensive financially and have the highest emissions. So we looked at what we could do to bring those down. Are there any waste streams, any area where we're using sharps or clinical waste inappropriately in high volume? And CT in particular had a very high sharps bins usage. And we discovered it was because staff were routinely disposing of the plastic contrast bottles into the sharps bins. Now, they could go straight into the clinical waste bins, and that would be a fairly straightforward project, but we thought, could we go a little bit further, be a bit more ambitious, and recycle them instead? So, the project is, can we recycle these bottles? So the first thing to do when you have a project like this is, who do I need to speak to open a door to get it to happen? So we spoke straight to the waste management team. Like, can these bottles actually be recycled using the existing processes? We needed to contact the manufacturer to get the exact specification for the plastics, because obviously not all waste management recycling, not all plastics can be recycled, and not all waste management teams are able to recycle the same plastics. The waste management team also told us it's really important for them to get the specifications for the contents and confirm the contrast itself was non-toxic. So we got the specifications for that. And then we had to speak with management, negotiate further recycling bins, so purchasing more bins. And then we wanted to communicate the change. So we produced this communications poster, and this was informed specifically by that feedback about which bin does which bit go into? What's the modality specific waste? This was negotiated with the waste management team, and they agreed that the medium itself could be decanted into a separate pot or a specific bottle, which was disposed of later in clinical waste. The spike itself is disposed in the sharps bin. The label, even though we have confirmed the contrast medium is non-toxic, they were not very flexible on this, and then we had to dispose of that into clinical waste separately, which is fine, and the bottles themselves are rinsed and disposed of in the recycling. And then we emailed the poster to all the radiographers and all the CT staff. They're on display near the pumps, near the bins. We held teaching sessions to educate what the change is, but also why we're making the change. And then identified a few people who were enthusiastic about the project to help champion it when either I'm not available or one of my other colleagues who's involved in the project was absent. And then last practical step, just get rid of the larger sharp bins so people aren't tempted to use those. We replaced them with smaller bins for needles, cannulas, spikes, etc. And then this is a second comms post we put together about specific waste management streams. So making sure people are using the correct bins, and then by having the cost and the emission stuff on the poster, it gives people a chance to pause and think, am I using the right bin? Is this really appropriate? And again, it's responding to that initial feedback saying, we would like to know which bin does this bit go into, okay? Sometimes they don't really know. Now, are people always doing it? No. Sometimes I come in on a Monday and this is what the bins look like. But I take this as a win, that the message has come through. We are recycling. There is, we are not disposing clinical waste or recycling in sharps, sorry. So we'll, make us another change. We make sure that there's either someone on the rota who's named, or the coordinator picks someone at the end of the day to spend 15 minutes going through that day's bottles and recycling them. And that way we can keep on top of them. And then my colleague actually audited the output, how many sharp bins, how many bins that they were using, and worked out per site about £10,000 saving a year and about 20,000 kilos of CO2. And that was per site, so that's a really big saving. And we put together this section on waste management for a paper that got published. And then me and my colleague was given a green AHP award, which was good for me. So this project, you could take it a little bit further. So what could you do next? And I think some of the other talks are maybe going to touch on this a little bit. But we can recycle the contrast itself, and we should be recycling it. It has an environmental risk to flora and fauna and risk of drinking water contamination. It can mix with sewage and groundwater, but I think the real problem is, even though it's non-toxic, it can mix with other pharmaceutical agents in the wastewater, which can create a toxic combination. The iodine itself is mined and manufactured overseas. It's a limited resource. There's emissions associated with mining, production, and transport. And then, quite aside from environmental sustainability, if you were trying to make this case in your department, there's a strategic or an operational argument for recycling the contrast. Because as recently as 2022, we had an acute shortage. And that was obviously that was a lag or latency related to COVID. But there's no reason to think there would never be any other supply chain disruption in the future. So I think it's worth contingency planning for that. Or making the case for contingency planning that. And unfortunately, as far as I'm aware, there's no ongoing recycling program in the UK. I read about one in Europe that's still in pilot stage, but I'm not sure what's going on with that. The ideal project described in the literature would be a more holistic approach that looks at your scan protocols and updating them, reducing the amount of contrast you're giving, and reducing the number of scans that actually require contrast. Do they all need it? And then reclaiming it either via catheterization or CT patient-specific toilets. This might seem a bit much, but there was a study last year that it was a single-site study, so usual caveats, but it said that they looked at the pharmaceutical agents in hospital wastewater and decided or concluded the highest concentration was contrast of all the pharmaceutical agents in hospital wastewater. So I think it's perfectly relevant to be looking at that. And that brings me to the end of my case study. Thank you very much for listening. I think we're going to do Q&A, I believe.
Thank you very much. Also, a very lovely presentation and cool project. I think we can start the Q&A. We have almost like 25 minutes to discuss. Maybe we start with some questions from the audience. Please feel free to use the Slido if you didn't use it. We have a couple of questions in there. I think both of them are for you, actually, Lauren. I don't know if you had a look in the chat function.
Yeah, so I can see two questions.
Yes.
One is, does couch paper roll have to go in orange bins if unsoiled? Could it go in domestic bin instead? Yes, it could. I spent probably 6 months before I did this project in trying to get it put into the domestic waste bin. But our ultrasound rooms are small. The clinical waste bin is immediately adjacent to the couch for reasons of hygiene. The domestic waste bin is by the sink for reasons of washing hands and putting the paper towels away. And the cognitive load on the department assistants of taking the 2 steps across to the other bin was not possible. It just didn't happen. Some of it did. And it happened if I said, oh, by the way, it goes in that bin. Every time I did an ultrasound. I do 60 ultrasounds a week. That's quite a few reminders. So yes, it can, but it wasn't. And also there is still a cost and a carbon association with producing, manufacturing and getting rid of domestic waste. Obviously lower than the orange waste bins, but still relevant, I think.
I have a question on that.
Yeah.
Actually, many things are regulated, but somehow no one knows why. For example, why do we use actually couch paper? If you want to, I know it's due to hygiene or whatever, but isn't there like other ways to do it? If you look in the operating room, they don't use any rolls. They just wipe it,
The infection control team, it was actually really interesting getting the infection control team involved. Basically, what we found was that there was a psychological cleaning benefit to spreading out the couch roll. And so the couch wasn't actually being cleaned in between each patient on loads of occasions. And the biggest objection to me getting rid of the couch roll was, oh, but then we have to clean the bed. Well, you should be cleaning the bed anyway.
Anyway, yeah, exactly.
The couch roll is purely cosmetic. I mean, if you go to a spa, sure, you might want to have like some tissue paper or something, but we're not running a spa. We're running a hospital.
I totally agree.
Like, I don't know. I personally was surprised at how invested a large number of people were in hanging on to the couch roll. It has really met with resistance. Yeah. And I've done a lot of kind of hearts and minds sort of stuff about the couch roll. And then in the end, I just ducked behind the cost saving team lady, Heather. She's a great person to hide behind, because actually when they saw how much money was saved, it was taken out of my hands. Even if I wanted to get the couch roll back, I wouldn't be able to now.
This is a very important thing. Radiologists love numbers.
Yeah.
We had a study how you can reduce energy with using deep learning sequences. and you can be faster. When you're faster, you can reduce. And we started to show them the results with like percentages, and they were just like, no, 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 that's not interesting. How much money it will save us. So I think it's very beautiful. Like you both showed like also like really touchable numbers, how
Yeah.
much money you can
Yeah.
save. I think this is a very important message, and especially for management or for people from the management who are just like actually their responsibilities like running the finances of the hospital or something like that. And this can also support your use case if you want to
Yeah.
put it through the hospital.
That was exactly what I found. The whole couch roll project really felt like swimming upstream. You know, there was a lot of resistance to getting rid of it. And then suddenly the cost saving team got involved and it was rolled out. I wasn't even consulted. It was just rolled out to the whole of the rest of the hospital because they saw how much money could be saved. I'm obviously thrilled because I think it's not necessary to use the couch roll and I think it's a carbon saving. But it was really interesting to me that like how you can utilize different people in your organization to work together because I felt like I was kind of battling alone at the beginning and then suddenly it was just done. And a lot of the projects that I've done have ended up being, once I've shown that they save money, they're away.
No, lovely. Then we can go to the next question. I think I
Oh,
see
yeah.
a couple of questions coming in.
So I'll just answer Evelyn Liming Ho's question. Is there data on paper couch roll versus disinfection wipe, which has the higher
Yeah,
ecological
that's good.
footprint? So that is an important, and it was raised by lots of people. Unfortunately, they are not exclusive. They're not like mutually exclusive. They're not either or. You should be using a disinfectant wipe regardless of if you're using paper roll. The paper roll is purely cosmetic. It carries no hygiene benefit. So that's like obviously why we were able to get rid of it. And then there was a question that was, how can we get our trusts more on board with improving domestic waste? I mean, that's a really complicated question. I think there's a couple of questions for Sam, and then maybe we'll go back to that gigantic question together.
Yes, that's good. So for Sam, I think the first question is, did you find any pushback from anyone in your department or hospital re-waste management and re-iodine management?
Yeah, that's a really good question. So I think similar to what Dr. Rams was saying, anytime you try and make a change, like which bin people were supposed to use, people were a bit resistant. So I think a lot of the on the ground resistance was probably from the radiographers themselves, being like, well, we've always done it this way. And the other resistance would have been when I was pitching the project to management about what I wanted to do. Part of that is purchasing new bins. And if you go to management and say, I would like to spend some money, they usually don't want to say yes. But I had two things to help support that argument, and I think it's really important that you are able to make a case that is useful for the management to hear. First is, well, we've done the attitude survey, and we know that there's a lot of grassroots support for it in the department, and I think that kind of influence is actually really useful when you're trying to convince management that their team is already sort of on board. So the actual cost of putting it into place afterwards would be minimal. And then the other thing would be, the back of the napkin math saying like, if we're using one recycling bin or using one less sharp bin, that would probably save X amount on how many bins we buy. So trying to make the case that this is not a short-term saving, but a mid to long-term saving. And then proving that afterwards, I think, has been really useful. Again, having champions for when I'm not in the room, though, has been really useful in encouraging the radiographers to participate. But once you've done the change, people forget that they didn't do it that way also. So like once it's happened, it's done. So it's really hard for them to then go back because that's another change. So
do you know, Sam, what happens with the contrast agent that you collect in this re-waste programs?
Yeah, so we did recycle it, and I sort of cut that slide. But we did recycle it before, but the manufacturer in the UK that was doing that paused it for whatever reason. I don't know why.
I know from Germany, they are allowed to recycle it, but they are not allowed to reuse the materials in a new contrast agent. They can use it for lab tests, they can use it for research, they can use it for other purposes or give it for other purposes, but they are not allowed to use it in producing new contrast agent. Is that also in the UK?
Well, the previous program we did have, I'm pretty sure they were using it to manufacture new contrast agent for patient use. But again, it's not happening at the minute; it's paused. So I don't know what that program is going to look like when it comes back. There was a question about the economic viability of doing it per hospital site. And I don't think it is like economic because that's you're building a new manufacturing process pipeline to do that. So, I mean, what we're doing at the minute is we're just decanting it into a single bottle or pot and disposing of that separately, which is not ideal. I don't really love doing it, but at least it's staying out of the wastewater, and it means we can recycle the remaining bottles. So it's A, positive, but it's not. I don't love it. But this is like a project I think we should be looking at doing.
Yeah, absolutely. I think what is very interesting is actually the last question. We can go through the others if we have time, but the last question, it is about this is something I've been asking also all the time when we started some sustainability projects in our university hospital in Tübingen. And the thing is, I mean, there are many strategies, there are many ideas how to do things. And in my opinion, there's a lack of how do we start, how do we measure things, and how we show it is cost effective. For example, Laura, you showed like the project with the cups. How did you measure this? How you do, how you can show like the business case, for example, or like the sustainability case for the hospitals, how you can plan such a project, because it's not like a very typical research project. It's like a different type of project or different type of investigative research that we don't usually do in radiology.
Yeah, absolutely. And since getting involved, I never realized that becoming sustainability lead for my department would involve me in learning so much about procurement codes and like the different waste street. Like it's all of the kind of the logistical running of the hospital is something that doctors don't usually get involved with. Like we reach for a needle, it's there. We reach for a paper, it's there. And the way that we demonstrated the saving from the cups was how many we were ordering before we did the change and how many we were ordering after. So they've all got a procurement code. How much money was spent against that procurement code before I did the change compared with how much was spent in the 2 months after I did that change. So it was just really obvious that we were ordering many fewer cups.
Okay, nice, very nice. I think this is a very good example how to calculate it. Very simple, So it's for us when we did this energy measurements, we just measured without the new technology, and we measured with the technologies, and we showed the difference at the end. It's almost a no-brainer, but for us also it was a little bit of a hurdle to, I don't know, to overcome how we can sneak in and check out how we do some procedures. There's a question for Sam. It's the last one. If you can see it, I have been trying to implement recycling of contrast bottles in Edinburgh, and he got told that pharmaceutical waste must be, it's regulated by law that it must be incinerated. And is this something that you can?
Yeah, I can. So obviously, law in Scotland may differ on this than it does in England, as far as so that usual caveat. One of the reasons why the waste management team were really keen for us to get the specification of the contrast medium itself was in this sort of reason was that to the layman it looks clinical, it looks like a drug. If you don't really know what you're looking at, they might see it in the recycling thing and then just say all of this actually needs to go into a different clinical waste pile now. So I think that's also part of their argument for why we should be removing the label as well before recycling, so it doesn't give people the wrong impression. I think this is more like it gives people the impression that it may be inappropriate, like toxic, but it's because we have the specification to prove the contrast isn't toxic for disposal and recycling, and because we rinse each bottle, I believe it complies legally. If not, the waste management team, they'll be down there.
Yeah, absolutely. Question maybe for you, Lauren. It's are tissues with septum without any blood have to throw into a medical or general waste box?
Sorry, I think I'm probably. Oh, yes, I see it. Are tissues with septum without any blood have to throw in the medical or general waste box? So any tissue that has body fluids on needs to go into clinical waste. You can't recycle that. You can't put that anywhere else. That needs to be burned. That needs to be incinerated.
Yeah, I think this is a clear recommendation, and then I wouldn't say it's everywhere in the world like that, but it's almost maybe everywhere in the world the same regulation. I would say it makes sense. Absolutely. And I need let's see which kind of questions. Sam, I have a question. The contrast agent projects.
Yeah.
Did you guys started some kind of project where you like recycle the materials of the contrast agent, or you just do like recycling programs of the manufacturers, or do you
Yeah, so
extract the ionodine and gadolinium yourself?
yeah, so it was just the manufacturer had a recycling program, which isn't happening at the moment. I don't know. I've not looked into doing it locally. I think that maybe that's a good project to look into. Yeah.
And
I,
we have, yeah, sorry, Lauren, say.
No, I was just
Go
going
for
to
it.
follow up. We've tried and tried and tried to get our iodine recycled. I've emailed, I'm going to say it, GE.
Yeah.
They were the ones who were doing the project. I've emailed them like 8, 10 times. I've got my friends to email them. All I get is a bland, we're not doing this. Basically, they need to have large volumes in order to make the recycling financially viable. I don't think any individual trust would be able to do anything with it. It needs to be going back to somewhere specific. I'm really hoping that the extended producer responsibility laws that are coming into place will start to feed into this kind of stuff. There may be exemptions for medical products, of course, but even if it's just a kind of mindset shift that actually the manufacturers of these products should be taking responsibility for the end use or the end life of these products, I think will be really, really helpful. But yeah, I don't think it's going to happen on a trust basis. I think it's going to happen on like a national level, maybe even country, like international, because of the volumes needed in order to make it financially viable.
Yeah,
And if I could,
and I think also maybe you need to tell them if you don't do this, we will change the vendor. This something can maybe make a little bit of a pressure. But what I also think is also maybe thinking about how to optimize our usage of contrast agent, that we don't have many rests. We noticed, for example, we have 4 CTs, and 2 of our CTs have like very modern contrast agent pumps. And the very modern one, we have almost no waste actually of contrast agent. So it's almost every time the bottles are empty with the last patient. The thing is, I must admit, there is a regulation about like you can use it only for 12 hours or something like that. If yeah, I think 12 hours is the time in Germany. Don't I'm not very sure if it's 12 hours, but let's say it's 12 hours. And somehow nobody knows where this time is coming from or something like that. Of course, they did some tests and they see at which time it's gonna have some bacteria or whatever. So it's not be able to be used. And I think manufacturers should also think about that, having like some system that can last longer or it can be used even longer without throwing them away. Because I don't know, because you used a new bottle at night and till the early shift you didn't scan anyone in the night shift, and then you have to throw 100 milliliter away or something like that. So, and I think there's a question also for Sam about how contrast, while contrast, it's from Kosovo. Hello from Kosovo for Sam. While contrast recycling protects the environment, is it cost effective for a typical hospital? I mean, maybe he means like a normal small
yeah,
volume hospital.
I mean, I think even if all you're doing is recycling the bottles, you're saving money. Recycling the contrast medium is a project we should all be lobbying our manufacturers to be doing, either via procurement or just informally when representatives are available. I think for any size hospital, I mean, the reason why, this is a project any site can do, really. I think it's really, and it will have savings, carbon and financial. Yeah. So I think regardless of your hospital size or how many sites you have or don't have, I think you can still do it.
At the beginning of these programs, I remember when we have with our German manufacturer, I wouldn't say the name of contrast agent, we talked to them. They had actually very cool ideas about like a rewarding system for the hospital if you join these programs. I don't know what happened from these ideas, but maybe at some point they will come back to that, like having some kind of you collect points for your hospital and you can buy the contrast agent a little bit cheaper or have like some kind of benefits. We have now 5 minutes to get back to the big question, actually. Matthias, thank you for reminding us. I almost forgot it, and I think it's a very big one. Like you said, Lauren, it's how we can get our trusts more on board with improving domestic waste. If we are all doing it at home, why can't we do this at work?
I think one of the things we did in my trust is I ended up lobbying the management so hard they ended up buying too many recycling bins. So we ended up recycling bins in every room basically, and it has actually had a big help just having access to it and having those posters up to say, put your cans in here, etc. So there's no reason why you can't do it. And again, put them next to water fountains, in the waiting rooms, every clinical room. You'd be surprised how filled they get.
Nice.
Yeah, I think it wasn't at the hospital I'm at currently, but it's a trust that I used to work at. They've had a really successful project where they've put the cost like 28p, 35p on top of the bin. So you see, 35p, that's an expensive one. And you think about what you're going to put in there. And then like, this is just 10p, I'm going to put it in here. And that's been quite effective because it's like really tangible to people. Like, of course, it's more expensive to get rid of clinical waste compared with domestic waste. But no, you don't really know until you look into it. But it's like a factor of a couple of times. So that's been quite helpful, I think. There's so many bins in a hospital. There's so many options and all the rooms are quite small. Like it's tricky. It is tricky. Which is why I really went to town on the like reduce bit, because if you're not buying it, you don't have to get rid of it. But yeah, I think Sam's point about having a recycling bin in every single room is brilliant. We've got hardly any recycling bins in my trust. I don't know why. It's impossible to find one.
Absolutely. What I personally highly recommend is we participated in the ESR Green ID, what you call it, Green ID certification. It is which is done by the subcommittee, the sustainability subcommittee, and they had a questionnaire actually that you must answer and submit to get your hospital certified by the European Society of Radiology. And what I found very helpful, the question that were asked there, you can actually learn a lot from these questions, or because they collected sustainability ideas, just like you said, Lauren. Don't reinvent the wheel. Just look what others have been doing. So they collected everything, and for me, I found it very useful. It's some kind of a summary of every initiative or every idea that you have. And we actually, it helped us to implement a couple of things that we didn't have. And now we're working on something. I had an exchange with Andrea Rockall where she showed me data about just shutting down the computers, and they somehow saved around 400,000 pounds, I think, per year, just by putting an automatic software to shut down the computers, which is amazing. And we are now working on that by just getting inspired by this project. So it's, I think it's exactly like you said, learn from each other. Let's collaborate. Let's just look what others have been doing and maybe try to implement these ideas. Thank you, everyone, for joining this session. We have a small break and then we will go to the other part, which is also very with very nice speakers. I wouldn't be the moderator. There will be my colleague Salah will be moderating this. And yeah, I would say have a good one and enjoy the rest of the session. Grab a coffee and let's go.
Good afternoon, everyone. My name is Evi Sala. I'm chairing this afternoon on sustainability in medical imaging. How do we optimize procedures, protocols, and resources? We've got three speakers, starting with myself, then Professor Andrea Lacchi, and then Professor Eric Bruno. We're going to go seamlessly from one to another so we can allow for more time for a discussion, which I really hope that will be a really lively and productive one. So let me share the slides. Okay. Perfect. Okay. So I'm just going to talk a little bit about sustainability by modality. Okay. Okay. So these are my disclosures. Okay, that's important. So we're going to go through a few things, a little bit of introduction, then on energy consumption by modality, suggestion how to improve, a little bit on AI and sustainability. Of course, AI is everywhere. And then we'll conclude with a few remarks at the end. So healthcare doesn't mean radiology only, but healthcare is responsible for almost 5% of the global CO2 emission, which is actually quite a lot when we think we're in a health business, you know. And the medical imaging is energy. So we are material intensive, we're energy intensive. So the radiology images are about 4% of the hospital's total energy consumption. And of course, demand is rising, as we know, it's actually doubling all the time. So, of course, you can see this really having a huge impact on the environmental burden. So, in a way, this is a challenge, but also it puts us in a position to really lead this shift to a sustainable radiology and a sustainable medicine. So, this is what it looks like actually, and when you think of that, of course you expect the MRI is the major contributor, and it's almost like one household with four people. You know, so it's really, when you put it that way, it's a really huge amount of energy is consumed. So I did a bit of a calculation what should be in our department. Actually, we're about to have a 7 CT very soon. But for what we have with this kit, which is a sort of medium to large department, it would be around 175 people, houses, 4 people maybe for a year. This is how much energy we use. So it's actually a bit terrifying when you think about it. So. A little bit of a definition, because then you'll be useful for the rest of the slides. Just what the net scan is, it's really the actual scan event in which the energy deviates from the baseline. It's when the images are required, the net scan. The active is when the scanner is used to examine, okay, a patient, which is preparation for planning of the scan, the reconstruction of the raw data, basically is how long patient remains in the room. So it's a little more obviously. Idle, and that's the problem when the scanner is idle, is when the scanner remains empty between the examination, okay? That doesn't mean it doesn't consume energy, it does, and that's the energy we want to sort of avoid being consumed. And of course, the system more means that the scanner is powered on and off, is powered off. So this is important to keep in mind. This is a very nice publication, which I really urge you to read. And really, it's scary how it goes, it's a big range, but up to 90% almost of the energy consumed by radiological devices was classified as non-productive. So we lose a lot of energy, and it doesn't produce value to the patient. Okay? And this is key to understand. Looking at modality, the CT, and again, more idle time consumption we have, energy consumption we have, you know, this is more than a net scan. So this is really 2/3 of the energy consumption on a CT is actually during the idle state, which is terribly inefficient. So what we have to do is we have to improve the workflow to actually lower that energy. So we address it. We need to optimize the protocols. We have to probably use AI to actually choose the appropriate protocol, and we'll get into that soon, I hope. Avoid the multi-phase overuse. Not everybody needs a CT with no contrast, arterial, venous phase, delayed, because obviously this also reduces some dead time. And again, very, very important, the workflow optimization. And of course, maybe use the auto shutdown or standby modes when the scan is inactive. It happens. And again, apply the AI and decision support to reduce those unnecessary exams and improve the planning, so you don't have that time when the scanner is actually not working, but consuming the energy. Moving to the MRI, I already told you that the MRI is actually more problematic in terms of the energy. 1/3 is attributable to the system off state. Really, off state, as I told you, means switched off, because you really have the constant helium cooling and the operation of the cooling head. So there, of course, there are the machines without helium now, and they are really energy efficient. But of course, it's not that you can replace your machines immediately; they do cost. But something to keep in mind if you were to really purchase a new MRI scanner, really be energy friendly. For the MRI part, the recommendation, it's the same for the CT to a certain point, to a certain extent. Prioritize the scheduling, reduce the idle energy losses. Important. Optimize your protocols so the scans are shorter, abbreviated MRIs, of course, answering the question. And then implement the on and off echo mode. So you reduce the energy consumption. It's been shown that cold head compressor power save cycles, they can cut off up to 30% of the energy. And of course, apply AI to shorten the protocols. And as I already said, go for low helium or helium-free designs where available, and if you're in a position to change the scanners, because obviously it's not that you're going to really go and immediately change all your scanners in the department. It's just not feasible. Intervention, again, is that energy which is used to power the climate control system in the interventional radiology suite. This is the major part, really. And then they cure at night and during the weekend. So actually, the suites are unoccupied. A little difficult how to address that, but again, apply an OR base. The operating rooms, section theaters, are actually very, very good into starting to being used to saving the energy. They have this strategy called reduce, reuse, recycle. And what it means, reduce, is power down the imaging equipment, computers, lighting outside the working hours, decrease that air exchange, don't use the air conditioner when it's not needed to be used. And of course, use the whatever you can use as materials within of course, compliant with the infection control. And of course, the rest of it, I know it's not, the machines don't produce the energy waste here, but there's a lot of waste outside the machines we're using. Every little thing that we use, it's actually it's not green in one way or another. So just moving to the AI on how to improve the sustainability, optimize energy use. Again, AI can improve your scan protocol and reduce the radiation and energy consumption. You can speed your MRI protocol, and you can automate your equipment shutdown to save the energy. Reduce the patient travel, optimize the schedule, redundant visits. That's all travel emission when you think about it, and everything helps in the global reduction of the energy. And of course, I mean, the teleradiology, there are pros and cons, so this is not the place to discuss it, but it does, in a way or another, minimize the energy used in general, out of the scanner room, of course. Reduce the low value imaging. Do you really need that scan? Build value with your imaging, because if it's no value, then it's all consumption in a way. And really, as I said, avoid the redundant scans. Use AI to manage the resources. You can predict the demand, reduce waste, optimize your inventory, improve your scheduling workflow. This is all leads per se. It might not improve it, but it leads to an improvement because you improve the process. So it's very, very important. It's a multi-chain process. Every single bit helps a lot. Again, here, I think this is sort of a conventional journey of the patient for a contrast CT. And I think in a future, this is a research project we're involved. It's not yet reality, but one day will come and we're going to actually generate digitally contrasting CTs from a non-contrast CTs, which mean much less energy consumption. Of course, think of those contrast injections and the iodine, which will be also reactions to the contrast. So no needle. This is the steps that we'll reach there, I'm sure. Moving to MRI, try to reduce their sequence, and this is a bit of work we're doing here at Gemelli, trying to reduce the whole body diffusion, the diffusion part from 25 minutes to 5 minutes, saving 20 minutes, reduces the all-over exam time, and also the images are of better quality because the patient is going to stay less in the scanner as well. So it's a win-win situation. Less scan time, less energy consumption, of course. However, AI has a cost, so it's a little bit of a balance. It is a high energy consumption per se, because you have to really, it's a continuous server operation, of course. And you can see here the equivalent of the data centers do consume quite a lot of energy, and so are the cloud services. So it's a bit of but the future is AI and the cloud. And the cooling water usage may reach quite an excessive amount. It was very interesting. By 2027, would exceed a small country being that, but the whole Denmark usage. So important. And again, you really have to think of the e-waste, the e-waste, which is very important because of all the upgrades they would really create toxic waste. I think this is just almost the very end of my slides. Again, top 10 actions that you need to implement. And I think you have to work together to implement those in your department. Maybe you have a champion to make it into a green department, and only that way you can really probably start having some effect. You don't have to do all of them immediately because it's not going to work, right? Department, but really choose your priorities and where you can make a difference. We have a huge role. We have a role on environment, on economic sustainability, social sustainability, of course. And we have to use AI to improve that. And then, of course, we also have our overall action as tech action have to be impactful as well. So it's a multi-direction and multi-layer process that we have to follow. It's complicated, but I think we can make a real difference. And change does begin the reporting room. I know that's like telling you washing your hands, but really there are little things that we can all do to, as they are listed in this table. It's a very, very nice, paper to actually start making a difference where you are, really. I thank you for your attention, and I'm going to really stop sharing the screen and give the floor to Professor Laghi. Thank you.
Thank you, Alice. Good afternoon, everybody. Let me share my screen. Okay. So thank you again, and of course, thanks to the organizer for involving me in this interesting course. So my topic is optimization of contrast injection. Those are my financial disclosures. So the question I want to answer is why do we need to optimize contrast injection? But there is an obvious reason, and the most obvious reason is because we want to improve our diagnostic imaging value. If you have a good contrast enhancement, you have a good diagnosis in most of the cases. But Today, we are not here to discuss about the diagnostic imaging value of contrast enhancement because we have to consider other different aspects of this injection. First of all, patient safety. Second, environmental sustainability. And third, economic sustainability. Let's start with patient safety. Iodine contrast media has a problem with nephrotoxicity. We know that most of the papers in the past reporting very high incidence of contrast-induced acute kidney injuries had been greatly overestimated. So we now know from most recent studies that there is absolutely no evidence of any risk for our kidneys when patients have a GFR more than 45 ml per minute. And it's also true that in very large controlled studies, there is no increase of either mortality or morbidity from contrast-induced AKI, even in patients with severe renal dysfunction. But it doesn't mean that we do not have to take care of the problem that patients with severe renal dysfunction might have a problem in their kidney. So nephrotoxicity is one of the issues. For gadolinium, I'm not talking about NSF because it has been solved thanks to the withdrawal of some agents by the FDA and EMA some years ago, and also because of the careful attention we put in the renal function of patients undergoing MR. But there is still a problem with gadolinium retention in the human body, even in patients with normal renal function. And that's true for brain, especially in the dentate nucleus and globus pallidus, for bones, for skin, for liver. And we know that this risk is higher with linear gadolinium chelates. Again, although it is not associated with a clear histopathological change and with no any clinical consequence, again, we cannot forget this problem. The other issue why we need to optimize the contrast injection is environmental sustainability. I think that those images speak more than 100 words. This is the environmental impact of iodine extraction. These images come from Chile, one of the areas where the extraction of iodine is most important in the world. There is a huge amount of water necessary to extract iodine, but it's not clean water, it's also polluted water. There is an issue of air pollution because of chemical gas dispersed in the atmosphere after the extraction of iodine. There is an issue of soil degradation, energy use, and also loss of biodiversity. For gadolinium, we have the problem of the so-called anthropogenic gadolinium. Now, it is the human introduction of gadolinium into the environment, which is a cycle. Now, a cycle starting with mining, continuing with manufacturing, and continuing also with the administration and the subsequent human excretion into the environment. Then the gadolinium goes into the water, in the oceans. It is again ingested by humans, by animals, excreted again, and it stays in the environment as a free molecule, which is, of course, very dangerous. The problem is not small, because if we consider how many doses of gadolinium have been injected since 1988, so when the first patient was injected with the first dose of Magnevis, well, it is more than 500 billion doses. And nowadays, we are injecting around 50 million doses per year. So gadolinium contamination of the ecosystem is an issue. And this is what happens when we inject our gadolinium in our MRI scanners. And it goes through the different areas, so in the water, animals, oceans, and so on. And there is an interesting paper from a French group of researchers looking at who are the main contributors to the pollution of the oceans. And so if you look at the Mediterranean Sea, for example, Italy, so we are the first contributor, followed by Turkey, France, and Spain. For the Atlantic Ocean, on this side of the ocean, of course, the number one is Germany, followed by France and UK. And in the Baltic Sea, the responsible is mostly in the hands of Sweden. And the same for the US in the Atlantic Ocean. On the other side, of course, China and Japan for the Pacific Ocean. Now, that's a big main problem. And the third point is the economic sustainability. Now, there is a rising cost of iodine and gadolinium. We know the increased cost of the products that we buy. Why is that? Because there is a demand gap. We are requiring more and more contrast, but the production capacity is limited. Because if you think about iodine, there are only two major players in the global market, which are Chile, with more than 60% of the global production, and Japan, with less than 30% of global production. And the rest in the hands of USA and other countries. So iodine recycling is one of the issue, which is now in place in some countries, with customer returning leftover or unused contrast media, or the return of unsellable product within the same company. And also the cost, we should sustain an increased cost of contrast injection. So it's better to personalize the injection, because if you personalize rather than using a fixed dose, you can save up to 20% of the volume. So you can save up to 20% of the cost of your hospital. So this is the scenario, now this is the background. But now, how we as radiologists, how can we react to these topics? Well, we should optimize the contrast injection with a very simple approach. Use the lowest effective dose, full stop. That's true for iodine, and that's true for gadolinium. Now I will go into more technical details to show you how we can do that. For example, if I'm working with CT and I need to optimize two phases, the arterial enhancer and the parenchymal enhancer. Of course, the impact of the dose is more on parenchymal enhancer, because we know that the arterial enhancer is regulated by the IDR, but it's not only the IDR. We can decide the volume. We can decide if, for example, for a cardiac CT or for a pulmonary CT angiography or a carotid angiography, aortic angiography, to use a fixed dose, or we can choose the exact volume. And we should choose the personalized volume. How to do that? Well, I'm making this example with the most common scanner in the world, the 128 slides. I'm not talking about fancy scanner, because I know most of the people are not using fancy scanners, but this is the most common scanner worldwide. 128 slices. I want to scan the cardiac CT. I need a cardiac CT angiography. How can I personalize the volume? Very simple. I look at the scan time. I look at the diagnostic delay. The diagnostic delay is exactly the time between the threshold and the hazardous scan. And it depends on the vendor. You have to ask your vendor, what is the diagnostic delay for my GE, Siemens, or Canon scanner, and they will reply to you. So you look at the scan time, 7 seconds. You look at the diagnostic delay, 5 seconds. You look at the flow rate that you decide because of the IDR, and that's all. 60 ml. Well, times 5, 60. 60 ml is the contrast you should deliver to have an optimal CT angio, or the heart in this case. No milliliter less, no milliliter more. And that's a first action we can do to save contrast. For parenchymal enhancer, the enhancer is much easier, so the impact is much greater. We know from historical data that to have a good enhancer means we need to increase by at least 50 to 60 ounce units between the pre-contrast and post-contrast scan. So it turns in delivering more or less 500 to 600 milligrams of iodine per kilogram of body weight. Now, again, please don't use fixed dose. Try to personalize according to the total body weight. Well, that's the easiest way. Just to tell you how to do. If you want to inject 600 milligrams of iodine per kilogram of body weight, it depends on the concentration of the contrast that you are using, and you have to transform these milligrams into milliliters. So if it is a 300 concentration, 600 times divided by 300 is 2 ml per kilo. If you are using a 400, 600 divided by 400 means 1.5 ml per kilo. So if I'm scanning a patient of 70 kilograms, 2 times 70, 140 ml for a patient when using a 300 milligrams concentration. If I'm using a 400, 1.5 times 70, 105. So this is exactly the way we can personalize the contrast. Is it a good idea to use the total body weight? No, not at all, because we know that with total body weight, we overestimate the dose because the contrast does not go into the fat tissue. So we should use the lean body weight. And for lean body weight, the magic number is 700. So 700, and I'll show you a couple of examples. This is a patient scanned with a contrast of 400 milligrams concentration. If I consider the total body weight, I use 90 ml. Same patient, few weeks later, unfortunately, in progressive disease, I'm using 80 ml according to lean body weight. So I'm saving 11% of contrast. 11% in one patient, 11% in another patient, saving a lot of contrast. Is it very complicated to the calculations? No, it's not complicated, but I know it's demanding. I mean, I cannot ask a radiologist in a very busy workflow to make all these calculations, which are easy, but you need time. So there are some apps developed on, and you can find for free in the App Store or in the other stores in the market, and you can put you can select the gender, select the formula, select the concentration, and you immediately get what you need, the volume that you should inject. Well, is it all? No, not at all, because there is something more with the new technology. Now, with the new scanners, we know that the contrast enhancer is inversely proportional to the tube kV. So if I reduce the kV, I can reduce less contrast. I can use less contrast, but of course I increase the noise. So I need to work with low kV in association with something reducing the noise. It was the alternative reconstruction a few years ago. It is deep learning, artificial intelligence now, when I can reduce the noise with a higher efficiency. How does it work? This is a recent publication in coronary CT angiography. We were able to work routinely at 80 kVp with a deep learning reconstruction, reducing the IDR and reducing the volume of contrast of 22% compared with a conventional scanner working at 100 kVp with ASIR, with iterative reconstruction. Can we do the same for the body imaging? So can the magic number 700 can decrease to 600? Well, the answer is no, unfortunately, at least with conventional scanners, no. And that's our recent paper showing that the quality of our images, if you decrease the milligrams of iodine from 700 to 600 using the lean body weight as a referral endpoint, it does not work. So we should do not do that. But in the future, with the spectral CT, with the photon counting CT, you probably will be able to do that. So you can reduce, because this is our ongoing study comparing, for example, 600 milligrams in a conventional CT, where we were using 120 ml in this patient, to 500 using a monoenergetic 50 kV acquisition for all the phases. And the quality is the same. And we are using 79 ml, so reducing the contrast by 30%. I do not have data. This is an ongoing study, but the future is the association of spectral photon counting with reduced dose of contrast. And if you wish, can we dream for using non-contrast CT, as already pointed out by Professor Sala? Well, this is a first patient, not study, first patient with a pulmonary embolism, scanned on a spectral CT without contrast. And this is the post-contrast, just to have confirmation that in this map, the so-called Z-effective map, we are able to see the emboli without any contrast injection. That's the future. So what about gadolinium? Well, the approach is the same. Use the lowest possible dose. Of course, the first point is to assess the appropriateness contrast examination. As I already mentioned, that there are many alternative techniques in MR, some of them not using contrast. So you should consider using non-contrast techniques, for example, MRA without contrast, rather than using gadolinium. You can use reduced doses of gadolinium chelates. That's something already in place since many years. If you look at these references, they are back in 15 19. There have been a lot of experiences using half dose, for example, of some of the conventional, let me use this term, conventional gadolinium chelates, half dose compared with standard dose in brain tumors, contrast enhanced MRA, liver, prostate, breast, showing similar performances. But nowadays we have an advantage. We have a high relaxivity and high stability contrast agents like gadopitinol, for example, which is already in the market, which has a target dose which is half of the dose of a conventional gadolinium. And in this comparative examination, we see the FNH is perfectly detected on 0.05 gadopitinol compared with 0.1 gadoteric acid. We can optimize also the acquisition. We can use, as already mentioned, AI, deep learning. We can, there are preliminary experiences on brain MR using 1/10 of the gadolinium dose by applying deep learning for image reconstruction. And there are now very preliminary experiences in synthetic T1 post-contrast images, so images without the use of contrast at all. So in conclusion, optimizing contrast media injection protocol is a good idea. It makes patients safer, the environment greener, and hospital administrator wealthier. Thank you.
So, hello everybody. I think I can go on with my presentation. My name is Eric Bruno. I am the manager of the Sustainability and Packaging Innovation Group within Bracco Imaging R&D. So let me share my screen. Hope you can see my presentation. So today, the focus of my presentation is mainly related to strategies that can be implemented to reduce the environmental impacts of contrast media, mainly in the environment. So this is my disclosure. As I mentioned, I am an employee of Bracco Imaging Italy. So as a general perspective, when we are talking about sustainability in contrast media, of course, it's very important to address sustainability throughout all the product life cycle. So this means identify risk and opportunities throughout the value chain, and when possible, to adopt circular principles and models to be implemented in the life cycle of the product. In the bottom part of the slide is somehow represented a simplified value chain of a contrast agent. Of course, according to the today object of the meeting, I will focus particularly on the end of life management of a contrast agent. So why is important? We already commented during today's presentation. So generally speaking, pharmaceuticals are now recognized as emerging pollutant in water resources, and this is well testified looking at the graph in the slide, in which is represented the increasing amount of publication targeting the pollution from pharmaceutical in different water samples, including wastewater, surface, groundwater, and drinking water. Of course, wastewater treatment plants, hospital effluents, and improper disposal are contributors to water pollution. There are a large number of different pharmaceutical products that includes antibiotics, anti-diabetics, and of course, specifically contrast media. Talking about contrast media in particular, it is to be underlined that iodinated contrast media and gadolinium-based contrast agent are excreted via urinary excretion, practically without being metabolized. And so they are accumulating in the environment, and due to the high stability that is of course a value in terms of patient safety and safety profile of the product, they resist to conventional wastewater treatment process. So the question is how we can reduce the environmental impact of conscious media. As a first step is trying to implement solutions to reduce the waste generation. So the first example I have today was something that we already targeted in the previous contribution for the speakers, is switching to a single dose approach to a multi-dose, multi-patient approach. This can be obtained by implementing an automatic injector designed for a multi-dose application that can help to optimize the amount of contrast media per scan, and also reduce significantly the waste of contrast media during the administration. Also, we can move on imaging bulk packages, so large volume parenteral that can help to reduce the amount of contrast media leftovers and also generate less packaging waste and of course transportation. I have reported here an example in the slide, just considering 5 bottles of 100 ml and 1 bottle of 500 ml, you can reduce the weight of packaging of roughly half by using the big bottle. So it is also beneficial for reducing the waste generation of packaging. Then, of course, we can reduce the dose by using a new generation of contrast media, and particularly for gadolinium-based contrast agent, by using high relaxivity product that with this high efficacy and kinetic stability are of course safe and effective for the diagnosis, but also allow for a dose reduction by half with respect to the standard dose. And just to give you a number that of course can be observed, if theoretically this product is used for 1 year administration in Europe, we can save up to 9 tons of gadolinium with respect to contrast media at the standard dose. Then also AI was addressed, and this is just a recap of what already commented. We can have different approaches to the implementation of artificial intelligence. One is related to the so-called contrast boosting, so using the level dose of a contrast agent and then increase the enhancement by the artificial intelligence algorithm. But at the same time, there are research lines aimed to implement these approaches with a dose reduction modality in which same contrast is obtained at a lower dose of contrast agent, just restoring the contrast by the implementation of the AI algorithm, down to the approach of the virtual dose in which you can have the same contrast enhancement at no dose of contrast agent. Of course, we are not yet there, but different groups are working to develop such a kind of implementation of algorithms for AI. Then we talk also about recollection of unused contrast media. So this is important to avoid improper disposal, and different companies have implemented the kind of take-back system that are normally applied with providing special canisters to hospitals, ask hospital to collect the unused product, and then the pharma companies collect the canister, and residues can be delivered for treatment for raw materials such as iodine reclaim. Of course, we commented about the possibility or not to reuse API or iodine for pharmaceutical purposes, and this is very related to the different regulations we have in different countries. So it's quite a tricky topic, and of course it depends about different geographies. In the end, what is important to underline is that the main contribution for conscious media entering into wastewater is the product excreted by patient urine. So a very powerful tool to decrease the environmental impacts of conscious media would be targeting urine of patient at hospital level. I will start talking about this topic by the study that was performed in Italy, the Green Water study that was performed in Policlinico San Donato in Milan, in which patients were asked to wait a certain amount of time after the administration of iodinated contrast media or gadolinium-based contrast agent, and then to collect their urine in specific canisters with the final aim to test the acceptance rate of the patient to wait and collect, and to measure the amount of iodine and gadolinium that can theoretically be recollected from urine. And results was absolutely promising on that, because acceptance rate was more than 90%, and mainly for iodine, the recovery was roughly half of the injected dose. So it is significant amounts of contrast media that can be recollected and avoid their entering in wastewater. So there should be different strategies to target the patient urine. In some countries in Europe, there are programs to distribute bags for outpatient that can be used at home, or if particularly for brand new built hospital, to implement specific wastewater treatment plants at the hospital level. In these two approaches, of course, we have the sustainability goal to avoid the emission, but we cannot apply strategies for circularity. This is not the case for urine collection and filtration devices that can be installed in hospitals and diagnostic facilities, in which the recollected urine or the recollected contrast media filtered by specific devices can be reclaimed for the recollection of valuable raw material such as iodine. And this is something that my company is going to perform in the near future, according to a pilot project we are going to implement in Europe, in selected hospitals in Europe, with the aim to test these collection and filtration devices and to test processes for the recollection of iodine. This is, of course, a very challenging project that involves different stakeholders. So it's not only pharma company, but we need technology providers, we need the collaboration of hospitals, and of course, we need the collaboration of patients, because the most critical point is the waiting time for the patient before urine collection, because the longer, the higher the amount of iodine that can be recollected according to the excretion curves of the iodinated contrast media. So we really hope that this will be successful and then can be somehow scaled up as a best practice for reducing the environmental impact of contrast media in the environmental water body. I think that is all from my side. Thank you so much for listening.
Thank you so much to both speakers. I think it was fantastic. Certainly, I learned a lot, which is wonderful when you keep learning, because then then it's really how it should be. Do we have questions? Okay, right. Well, so far we have one question. Let me just start with the one question. The AI systems are also costing the company. It should be very helpful, but to trust in those, especially clinical imaging like P or stroke or trauma. What do you think? Thinking of the P, I think I'm gonna ask you, Andrea. I'm gonna put you under the spot. So, but basically, if I understand the question correctly, is the AI also costs, obviously. So, should we use AI in a way or another for everything, or just the life-threatening? I mean, both speakers. I'm starting with Andrea.
Thanks, Evan. No, that's the usual question when talking about AI. I think that it is a matter of maturity of the market. Let's put it this way. So at the moment, I see a fragmentation of the AI market. There are too many companies, too many products, too many vendors, and the offer follows a business which is sometimes not the same business model that we use in hospitals, especially maybe in public hospitals in Italy, but also in other countries. I think that when the business model will change, when the market will be more mature, when there will be more aggregations, the problems of the cost will be solved. So it is a cost, sure, but as it is a cost, a scanner or an injector or a contrast, but the cost will be sustainable. Nowadays, it's not sustainable because if you have to buy 10 or 15 different products from 10, 15 different companies, maybe for solving a problem of 2, 3, 10 patients per month is something outside of a reasonable business model. So this is my answer. I think we have to wait. At the moment, yes, it's true. You should choose the product that you need, considering the patients that you have. If you work in a trauma center, you would choose for a product helping you in detecting bone fracture. If you work in a different environment, maybe in ambulatory with no emergency, you do not need those kind of products. If you do not have a stroke unit, it's useless to buy a stroke. So it depends on what we are working on, but I'm really sure that the market will surprise us in a few years, not now.
I agree, and in fact, if I might add, this is part of a consideration when you buy a system. Of course, as Professor Lacchi said, what center are you, what do you need, but also the AI you buy, does it actually bring you added value that would be system value, health system value, workflow, reduce the time of reporting, which brings patient value ultimately in one way or another. But all direct patient value, maybe you don't optimize the flow, of the scheduling, for example, but maybe your accuracy goes up if you use AI, especially because they don't have specialized readers. It's a bit of a considering everything. But again, the market will surprise us as it does with AI anyway. So, Eric, anything to add?
No, yeah, but just what we are saying, of course, this is also important for the high throughput, so it's not only relevant to the single specific case, but also to help technician in diagnosis, because of course they are overwhelmed, and we know very well that this should be an issue for the workflow of an hospital. So yeah, I think it is also beneficial in that sense.
Right, okay, we're warming up. I love this. Another question, AI can both cost a lot of energy, absolutely, and potentially save a lot of energy. Yes, and not just energy, save errors, or save a lot of other things. Do we require robust legislation to ensure transparency regarding the energy cost? Really good question. So we know if energy is really being saved. Gosh, this is almost we need a forward-thinking lawyers. on the legislation. I don't know how to answer this one, actually. I think it's a bit of a, I mean, already we have a fair amount of legislation on AI, which I think is a fine balance between suppressing creativity and allowing safety, right? Because you've kind of, they go hand in hand. But should there be legislation that I guess there's legislation on the calories you have on the food. Now you declare it. Maybe on the product will be somehow energy, I think it will probably come, actually. I don't know. Eric, I'm picking you because you on an industry. Let's say, should tomorrow be stated?
Yeah, I think that as a general answer, of course, every time we are going to implement something, we need to consider the environmental impact, of course. So there are tools that we can use to evaluate benefit and cost of what we are doing. And this is the approach we normally use. So we can use the LCA evaluation, we can use different tools to evaluate this. Of course, AI is something that is skyrocketing in each aspect of our life. So it's not by chance that also in diagnosis that at the end is images evaluation should be very important. So the point is not rather how we are going to implement it or not, but how can we make it more sustainable, less impacting, because to be completely honest, there is an impact, of course, in energy, also in water consumption. So yeah, this is absolutely what we are trying to do, and balance benefit and cost of this implementation.
Exactly, and I couldn't agree more. Andrea, anything to add in there?
No, I think, yeah, it's a political issue rather than a radiological issue.
Exactly. Actually, I'm coming back to you, Eric, because there's a question which actually regards the bottle. So it's got to be you. If the company recollects the glass bottles of contrast and sterilize them, can they be used again?
Right. Good question.
Yeah, it's an hard one. It's an hard one because it's each time is not a matter of technical issue. We can do this in a very simple way: collect, sterilize, and reuse. The point is regulation again. So in different countries, we are allowed or not to do some approaches to be circular. So it's very hard because, for example, in Italy, we are not allowed to. And this is, of course, something that we would like to address also with lawyers and policymakers, because somehow we need to work a little bit together to overcome the boundaries. There was a comment in the first part of this meeting in which one of the speakers told that a company discontinued the service of take back. And yeah, this was for regulatory aspects. And of course, also in Europe, different countries, different regulations. So what you are allowed to do in a single country, maybe you're not allowed to do in another. So it's very difficult to harmonize the approach for sustainability, but technically, there is no issue to take back a glass bottle, sterilize and reuse.
In fact, no, I agree. Any other questions we've got? Well, actually, we've got only 1 minute to go. So, any burning questions? Okay. No. Go. Okay. Well, I think. No. Okay. I think this, at least I've learned, I think this has been a brilliant session. Since I forgot to thank the ESOR and ECI at the beginning, I'll do it at the end. I think these sessions are wonderful because it goes a little bit beyond radiology, and I think that it puts us being a responsible citizens and doctors as well, beyond the patient care. I think it's important. But I especially want to thank my co-speakers. Thank you so much, guys. It's been fantastic lectures, which I enjoyed. And thank you all the supporting staff from the ESOR office, because they're absolutely amazing. They keep us straight in line. And thank you to all the participants and to the brave ones who answer the questions. There you go. There's no stupid question. All questions are intelligent, as a matter of fact. And have a great rest of the day and have a great summer.
Thank you. Bye, everybody.
Bye-bye. Thank you.